In this recap session, we will review how to solve systems of linear equations, in particular systems of 2 and 3 equations. This means finding values for unknowns x, y, and possibly z, such that 2 or 3 equations are true simultaneously. First, we look at a system of 2 equations. We have x plus y is equal to 0 and 3x minus 2 is equal to 3y. And now we have to find values for x and y such that these 2 equations are true simultaneously. One way to solve such systems is to start on the top equation, work your way down and then back up again. And this is how it works. From the first equation we find that x is equal to minus y, and this information can be used in the second equation, where we can now replace x by minus y. This gives us an equation that only contains y. Minus 3y minus 2 is equal to 3y. It can therefore be solved to find a single value for y. And in this case, we find that y is equal to minus 1 over 3, our first solution and 1/2 of the way done. Now we work our way back up again. Since we got a relation between x and y from the first equation, and we have found a value for y here, we can now deduce a value for x, namely plus 1 over 3. And therefore, our complete solution is x is equal to 1/3 and y is equal to minus 1/3. As always, a good way to check whether you made any mistakes is to plug in the solution in our original equations and see if they are indeed true. And in this case, they are. The same procedure can be done for a set of 3 equations with 3 variables. Again, we start with the first equation, working our way down. For the first equation, we isolate z and find that z is equal to 2x minus y. Then moving to the second equation, we can use this information and substitute z with 2x minus y. Having eliminated z, this gives us an equation linking x and y. In this case, y is equal to minus 11 times x. Moving down again to the third equation, we first eliminate z by substituting 2x minus 1, and then we eliminate y by substituting y is equal to minus 11x. This results in an equation in which only x occurs, and it can be solved to find that x is equal to 3. Then, having our first solution at hand, we can work our way back up again, finding y and z. Since y is equal to minus 11x, we know that x has to be equal to minus 33, our second result. Then, moving to the first equation, we know that z is equal to 2x minus y, and filling in x is equal to 3 and y is equal to minus 33, we find that z is equal to 39. Having found x, y, and z, we have our final solution. If you want more practice on any of those 2 scenarios, I have dedicated videos on each of them. And as always, I thank you for watching, and I will see you in the next one. Bye.